Hello, seventh grade, and happy Tuesday, May the 5th. That is, I believe, it's a date of a major battle in Mexico, which helped get their revolution going and on the way to independence. So it's sort of a big day, Cinco de Mayo, May 5th in Mexico. Um, it's also Taco Tuesday. So it's kind of like Taco Tuesday on May the 5th, Cinco de Mayo. So we got that going for us, and it's sunny today. Tomorrow's supposed to be a rainy day, so I'm going to get outside today and to get some more sunshine on this pale skin and long hair. Today we're going to jump right back into genetics because yesterday it was a lot of fun figuring out the probability of whether it's going to be a tall or short pea plant. And today we're going to figure out the probability of the pod color. All right, so let's get into it. All right, so here's some of the variations that a pea plant has. And pea plants are good for this because they have a lot of traits, a physical characteristic that it's either one or the other. It's either going to be tall or short, yellow or green, purple or white. And you can figure out the probability, what you're going to get. And so we're going to do that with this right here, the color. Because when Mendel crossed his pea plants, he would notice that most of the time he would get green, but some of the time he would get yellow. So he's like, let's see what's going on here. So let's see what's going on. Let's try to see what's going on. All right, I've made this structure here, and we learned yesterday this is called a Punnett Square. And a Punnett Square is used to determine the probability of the traits that will be displayed by the offspring of something. Puppies, kittens, bearded dragons, you, a pea plant. So we're going to do that, and we're going to get our font a little bit bigger. Determine the probability of passing down traits from one plant to another. That's the study of genetics. And the genetics is the study of heredity. And heredity is passing down of traits genetically through the DNA from parent to offspring, whether that be parents, a parent cow or a parent horse or a parent pig or parent plants to their offspring. Okay? And the phenotype, the trait, is going to be the pod color. That's what we're going to look at. Okay? The pod color. Now, the letters you can use are arbitrary, but generally you go with something that we're discussing. So we're talking about the color. And we have two possibilities. We have dominant and recessive. Dominant is a trait that will appear in the organism. If you have the dominant trait, you will see that. Okay, like yesterday, tall was dominant. So anytime that the offspring had a capital T, the plant was tall. Even if there was a big T and a little t, the dominant trait wins. The recessive trait is the one that gets covered up. You don't see it. You might have a gene for being tall or colorblind or green hair, but if it's the recessive trait and you have the dominant trait, you won't see that. Okay, so green is the dominant trait. So we're going to use capital G, and that is dominant for green. Lowercase g then is going to equal recessive, and that means it would be yellow. Those are the only two choices for the pea plants. Okay. So the genotype, there's different ways where you're going to get genes from mom and genes from dad. Gene, member, is a piece, just a segment of the DNA. that controls the color. There's a piece of the DNA that controls the height. There's a piece of the DNA that controls whether the inside is yellow or green. There's a piece of the DNA that controls whether the pot is wrinkly or smooth. So a gene is a piece of the DNA. And you're going to get a piece of that DNA from the mom and a piece of that DNA from the dad. And whichever one is dominant in that situation is going to win out. And allele are the possible allele, my spelling, allele. Let's go to our website and check our spelling. It's a little early for me. I'm doing this before 8 o'clock, so bear with me. Start over. Sure. Trait, physical characteristic. Heredity, study of genes from parenthood. Genetics, the study of heredity. Purebred, we will get to that. Genes, segment of the DNA. Just a segment. Allele, did I have it right? I think I did. It didn't look right. Allele, gene combination. It's the gene combination. So one of the possible alleles is you get the dominant trait from mom and the dominant trait from dad. Okay, well then you would definitely be green because green is dominant. The other possibility is you get a dominant trait from one parent and a recessive trait from the other. You are still going to be green because you possess the dominant trait right here. It'll cover up this one. If you get a recessive from mom and a recessive from dad, or either way around, you will be yellow. The reason you'll be yellow is because you do not have the dominant trait. Okay. So this is called the genotype. On this side, we'll space this out a little bit more. The genotype is how the alleles are combined. Do you have big G, big G, big G, little g, little g, little g? That will determine then the phenotype, and that means the physical characteristics that you see. What's its phenotype? It's green. What's its phenotype? It's yellow. I wonder what the genotype is, the combination, to get that phenotype. It's like cause and effect. This happened, so you see this. This happened, so you see that. This happened, so you see this. All right, let's run the Punnett Square. We'll put mom here, mom plant. Usually they say like plant 1 or plant 2, but I like saying mom and dad plant because it's more fun. All right. So do we want mom to be green or have pods that have green or yellow? Let's have her have yellow. That means the only way mom could have yellow is if she had an allele combination of G, G. Because if she didn't, if she had anything else, she would not be yellow. Mom must have GG as a genotype because she's yellow. Now, dad, we could make dad green. We're going to make dad green. And let's say he could either be this version of green, of a genotype dominant, or he can be this version right here. This one, he would still be green. Or this one, he would be green because he has the dominant trait, the dominant gene right there. So let's make dad, let's make him capital G. capital G. Okay? He is definitely green because both of his genotype, his allele combination from his mom and dad, from this dad, from his mom and his dad, he inherited a capital G and a capital G here. So that's what he has. Okay? We'll get rid of these so you don't get confused. And this mom plant, from its parents, must have inherited a lowercase g and a lowercase g, at least because she has them. She got them from her parents, and they got them from their parents, and they got them from their parents. Study of heredity. All right, let's run the Punnett Square. So in the process of reproduction, you get information from mom and information from dad. Okay? So you get one allele from dad and one from mom. This one, and I'll just draw on this one, this comes in here, this one comes down for this square. So for here, G, G. All right, now pick a different color. We're going to do block 2. This G comes across, this G comes down. So you end up with capital G, lowercase g. Now, this one comes in, and this one comes down. G, G. And this one comes across in this situation, and this one comes down. Hopefully that doesn't make it more confusing. G, G. All right. I'm going to erase those lines because that looks crazy. All right. So now let's look at the probability of the offspring. Block 1. What's the genotype? It's GG. That means it's going to be green. Or green. Block 2, this offspring, GG. Nope. GG equals green. Block 3, GG. It's going to be green. Block 4, the genotype, GG. Phenotype, green. So the probability of having a phenotype of green is 4 out of 4 or 100%. If you cross a pea plant that is yellow, and because it has 2 lowercase, and it has then a green, and the reason it's green is it has GG, dominant, every single one of the offspring will always be green. Every will all be green because this dominant gene is going to cover up this one, and this one will show up, and that one equals green color. Okay? So I would suggest a couple of things. Vocab in your vocab section. Notes like this in your notes section. And then try this, but do a different combination. Put capital G, lowercase g, capital G, lowercase g. Okay? Do this allele combination on both. Okay? Do this one with this one. Okay? And see what you get for the probability of the offspring. All right, everybody. I hope you have a great day. Remember, tomorrow is our live Zoom where we're going to be reviewing all this. I'm going to take your questions. You're going to ask me questions. It's going to be awesome, I think. All right, so long.